A lightning strike or lightning bolt is an electric discharge between the atmosphere and the ground. Most originate in a cumulonimbus cloud and terminate on the ground, called cloud-to-ground lightning and cloud-to-cloud, where discharges only occur high in the atmosphere. Lightning strikes the average commercial aircraft at least once a year. But modern engineering and design means this is really a problem. The movement of aircraft through clouds can even cause lightning strikes. A single lightning event is a flash, which is a complex, multi-stage process, some parts of which are not fully understood. Most CG flashes only strike one physical location, referred to as a termination. The primary conducting channel, the bright coursing light that may be seen and is called a strike, is only about 1 inch in diameter. But because of its extreme brilliance, it often looks much larger to the human eye and in photographs. Lightning discharges are typically miles long, but certain types of horizontal discharges can be upwards of tens of miles in length. The entire flash lasts only a fraction of a second. Lightning strikes can injure humans in several different ways. Warning signs of an impending strike nearby can include a crackling sound, sensations of static electricity in the hair or skin, the pungent smell of ozone, or the appearance of a blue haze around persons or objects. People caught in such extreme situations, without having been able to flee to a safer, fully enclosed space, are advised to assume the lightning position, which involves sitting or crouching with knees and feet close together to create only one point of contact with the ground. Lightning strikes can produce severe injuries and are lethal in between 10% and 30% of cases, with up to 80% of survivors sustaining long-term injuries. These severe injuries are not usually caused by thermal burns since the current is too brief to greatly heat up tissues. Instead, nerves and muscles may be directly damaged by the high voltage producing holes in their cell membranes, a process called electroporation. In a direct strike, the electrical currents in the flash channel passes directly through the victim. The relatively high voltage drop around poorer electrical conductors causes the surrounding air to ionize and break down, and the external flashover diverts most of the main discharge current so that it passes around the body, reducing injury. Metallic objects in contact with the skin may concentrate the lightning's energy, given it is a better natural conductor and the preferred pathway, resulting in more serious injuries, such as burns from molten or evaporating metal. At least 2 cases have been reported where a strike victim wearing an iPod suffered more serious injuries as a result. However, during a flash, the current flowing through the channel and around the body will generate large electromagnetic fields and EMPs, which may induce electrical transients within the nervous system or pacemaker of the heart, upsetting normal operations. This effect might explain cases where cardiac arrest or seizures followed a lightning strike that produced no external injuries. It may also point to the victim not being directly struck at all, but just being very close to the strike termination. Another effect of lightning on bystanders is to their hearing. The resulting shock wave of thunder can damage the ears. Also, electrical interference to telephones or headphones may result in damaging acoustic noise. About 240,000 incidents regarding lightning strikes happen globally each year. According to National Geographic, annually about 2,000 people are killed worldwide by lightning. Therefore, the average human being, according to these figures, has roughly a 1 in 60,000 to 80,000 chance of falling victim to lightning in an average lifetime. Furthermore, due to increased awareness and improved lightning conductors and protection, the number of annual lightning deaths has been decreasing steadily year by year. According to the NOAA, over the last 40 years, the United States averaged 51 annual lightning strike fatalities, placing it in the second position, just behind floods for deadly weather. In the US, between 9% and 10% of those struck die, with an annual average of 25 deaths in the 2010s decade. In Kisii in western Kenya, some 30 people die each year from lightning strikes. Kisii's high rate of lightning fatalities occurs because of the frequency of thunderstorms and because many of the area's structures have metal roofs. These statistics do not reflect the difference between direct strikes, where the victim was part of the lightning pathway, indirect effects of being close to the termination point, like ground currents, and resultant, where the casualty arose from subsequent events, such as fires or explosions. Even the most knowledgeable first responders may not recognize a lightning-related injury, let alone particulars, which a medical